in at short notice to give a presentation on big data. So what I'm trying to do here is, I've given presentations on big data before from a very technical perspective, and the bottom line is a lot of people don't think big data is a really particularly relevant subject for them because not many people have many petabytes of data. So what I'm going to try and do here is to just go through things from a more general perspective and try and relate what's happening in big data to what's happening in production environments that kind of most of the people here will be involved with. If you've got any questions or anything, at any point, it's well structured. Okay, so big data. I believe it's a path that kind of everyone who's currently working in IT is on. Everyone's at a different point in the path, but I hope you'll see that it's something that's relevant to all of us. Okay, so as all presentations do, it starts off with a quote from Wikipedia. Big data is the term for a collection of data sets so large and complex that it becomes difficult to process using on-hand databases or traditional tools. Well, you know, that is big data, and what it's really saying is something that all of us are very comfortable with in IT, because all of us at some point have had to deal with some element of technology whereby the tools that we're currently using get superseded by the amount of data we're processing. We don't have enough processor power, don't have enough disk space, all sorts of issues. And so some of this presentation will cover elements that have happened in the past, how they've been overcome, elements that are happening now inside current infrastructure, and how they're being solved with technologies and processes that were really designed to operate in the big data space, but as all technology does, it trickles downwards and are part of our current infrastructure. Okay, so this goes back to the hundreds of petabytes thing. We all think we're never going to get to big data, working in a production IT environment. We look at the amount of data we've got now. Maybe next year we'll have twice as much. That's still not as much commonly given as examples of what's being big data. But if we have a look at supporting principles of big data, we've got increasing storage, we've got increasing requirements to do intelligent search. There were lots of concerns around sharing data and the bandwidth, transferring data temporarily and permanently to other organizations and other individuals, and then analysis of that data. So they're part of the big data definition, but we do all of these things right now. So what's different? What's changing? Okay, just going to look at storage, one of the most basic fundamental bits of data. Disk drives and error rates. So disk drives are getting a lot bigger than they used to be. The amount of disk space available on a single drive tends to double every couple of years, which is great news for everyone. One of the things that isn't great news is that nothing has really changed in the fundamentals of the way a disk works. So you're always stuck with an unrecoverable data rate on any device that you can go and buy today. And that includes SSDs. It might be like 1 in 10 million times, but you're going to get a bad unrecoverable sector at some point on a disk that's inside your organization. If you're doubling the amount of available data on a disk every 2 years, effectively you're doubling your risk. And where that particularly matters is disk arrays. So commonly inside my professional life, people will come to me and they'll say, well, we'd like to buy this RAID disk array, and let's have a look at the disks on the market. Can we put, for example, 3 or 4 terabyte drives inside this RAID array? And the answer is not really, because you can put them in, and the problem is that you then can't do a RAID rebuild on them. So because the amount of error rates remains the same, the reason why RAID 5 works at all is you put a parity stripe across the disks, as you'll be aware. One of the disks fails, you get a new drive, you plug it in, and then it reads all the drives and rebuilds that one drive. So if you just step back for a moment and have a look at the process, at the point where your disk drive has failed, you've got no redundancy left on your drives, just the data. So you need to rebuild that to get your redundancy back. What are the chances that one of those unrecoverable data sector errors at a hardware level exist on any of those drives that are remaining inside that set? Well, the chances are directly related to the actual size of the disks. So if you're looking at having a 5 array, and you think, well, next year I might put 4 terabyte disks in it to give myself some storage, the issue that you're going to have is you're almost certain to have an unrecoverable error on that array. You'll take a drive out when one of them fails, put it in, it'll get halfway through the rebuild, it'll be an unrecoverable error, and you're coming back from tape, basically. So if you look at the kind of drives on the market today, you can buy 3, 4 terabyte drives. If you try to put those in a RAID array, the chances are that the risk of not being able to rebuild your RAID array within a certain time frame or level of certainty that you're actually going to get your data back. Also, if you think about things like high capacity disks, if it takes you a day just plugged into a controller to read the disk drive byte by byte, top to bottom, you're running without any redundancy for all the time that disk's rebuilding. So even without errors, one drive fails, you plug another one in. If you're talking about days to rebuild like a RAID 5 array, you're exposed for that time. And as we all know, once one disk fails, they're all from the same batch. You put strain on them with a RAID recovery, another one will probably go. So you'll be very hard pushed to go out and buy a RAID 5 array from a reputable SAN manufacturer these days. So we've switched to RAID 6. So now you have an extra parity stripe. And what that allows you to do is it allows you to recover from 2 disks. So now you've kind of your risk. But halving your risk is only going to last you another 2 years. So for practical purposes, RAID 5 is already kind of not good enough. And when I say this, you can fiddle at the edges with all kinds of technology. Depends what kind of disks you use. SATA are particularly problematic. Flash drives are particularly problematic, etc. And some controllers will allow you to rebuild a RAID array even though you've lost data, and you will just get a small amount of corruption you can deal with. RAID 6, again, like I say, if this continues to double, maybe we've got another couple of years out of that. But ultimately, in terms of technology which is striping disks, isn't going to carry on scaling forever. So what we have in the future is we have object-oriented storage. And the good news with RAID and striping and parity is that after that technology was invented, people got better with the algorithms. So instead of having a drive array where you can have one failure in it, and it's a static equation, you can have a whole bunch of disks, and for each object that you write into them, rather than the file, you can say, okay, this object has got a particular policy associated with it, so I want to stripe it across 11 disks and accept failures on any 4 of those. Or you can do the maths, and these objects can coexist inside an object array with different recovery profiles to them. And that object storage has been deliberately has been derived from big data processes. So if you wanting to build a scaled distributed object-oriented big data network to store your theoretical 10,000 petabytes of data, you would have to use that technology. What we can see is the devices that are supporting object storage are now coming down and down in capacity. So you can buy object stores of maybe 30, 40 terabytes, which is down kind of at the mid-range SAN scale. Striping versus erasure coding. Really, that's kind of the maths and with it. RAID is striping and gives you fixed parameters between how many disks you've got, how many failures you can accept. Erasure coding is the algorithm which allows you to say, I will accept 3 failures in a group of 30 disks. So that's storage. Search. Okay, anyone who's ever been in IT with a company that's gone through acquisition, for example, is a good example, will already know hierarchical file systems are already getting too deep. Now, again, that varies from operating system to operating system. Also, varies from application to application. For example, companies that have been acquired and we have to take their entire directory structure and put it underneath somebody else's directory structure in a Windows environment can have all sorts of problems. We did this for one company and they were running the latest version of Backup Exec. And although the actual Windows service could handle the file structure being that deep, Backup Exec couldn't. So when it was trying to build its files and you would go down, you would try and tag something down at the bottom, it was taking forever for the system to parse it up into memory just because of the way they'd written the program and the rest of it. So to actually back up the data at all in that hierarchical file system, we had to go into the hood. We had to copy the whole thing to an object store and then do an object backup of the whole tree structure. And that's just like a technical issue. Obviously, navigating a hierarchical tree is a real problem. How do you get around this? Well, there's another big technology idea, using metadata. So obviously, on the Windows side of things, you can index your drives to allow yourself to have fast search on that. And it will create some metadata on the disk, and it will allow you to search for files and folders. Not very smartly, because the amount of data, so the type of metadata that you've got on the disk isn't actually that much different to the very poor stuff you had in the hierarchical file system. So you imagine you've got all of these unlabeled objects and you've got to sort through them on file name, maybe a bit of text in them if it's a text file. You wouldn't design your metadata like that. It's just what's available. And if your primary bit of metadata that you've got a file is where you put it last, the chances of losing things or the chances of people finding useful data are very small. So, to get around that problem, we've got some current technologies. Is anyone running SharePoint? Excellent, great product. So what's interesting about SharePoint is that actually it tries to do much of the same functionality that you'd want out of a big data object file system, but in a much smaller package. So what they've recognized inside SharePoint is that basically your hierarchical file structure isn't really so great at doing all these meta data functions. So what they choose to do there is, okay, it doesn't say you've got to have an object-based file system, but you can't use the hierarchical file system either. So what it does is it treats all of the objects as blobs, pulls them inside a database, and then uses the database as a kind of object store where you can have a file with some metadata, which SharePoint comes with filters for Word and Excel and the rest of it. So it'll have some more useful information in there if you put it in. So it fulfills the search criteria. And also it supports revisioning at its file system level. So when you go into SharePoint, you can say, give me the file it was last week, or before someone made some revisions to it. And because you've got people working on the files as well, you can see how many times they've been hit, whether or not files are being particularly useful for people. All great stuff. So it's fulfilling the functions you want from a big data system, but at a small scale. Again, SharePoint, as anyone who's running their own organization will know, is you have to be able to scale your SQL backend to get the performance you want out of it. Exchange is also a great solution. I guess a few of you might run that. Exchange has also got functionality inside it you would commonly find in a big data backend. That really is deep. It didn't come straight away. I was an Exchange administrator back in the day before it had deduplication in it. And one of the most common tasks you would have to do is, back in the days when disks were small and expensive, someone would always have the bright idea of sending a picture of the bacon baps that they'd bought for everyone because it was their birthday, or I suppose it would really be odd pasty, wouldn't it, on the Isle of Man. And they would send it out to everyone inside the company. So even like, that yard of pasty bitmap, by the time it's been duplicated, 1,000 times, would tend to cause Exchange to run out of disk space because it wasn't smart enough to know that there was one source of data and multiple recipients. But they fixed it. I can't remember, it was 5.5 or 2000. It was able to deduplicate the blobs that were inside the mails. And again, being typical Microsoft, they've solved the problem of the data sizing inside that in a completely different way to SharePoint. In that back in the day, they also recognized that hierarchical file systems weren't the way to go. Interestingly, Microsoft used to have a different product called MSys, which was a ISP level mail system, which did have an underlying hierarchical structure. They ran that, in conjunction with Exchange, and they built, the MDB system that Exchange administrators are always fond of repairing and running. So what that is that's it's an object-structured database, but unlike the SQL that underlies SharePoint, it's completely proprietary. But nevertheless, underneath, there are all objects like your mailbox, the attachments that are in them, all sorts of different bits and pieces you can get at with an API. And for as long as I can remember, Microsoft have been saying, version of Exchange, we're definitely going to get rid of this proprietary MDB stuff. We're going to go to having a SQL backend. I think the first time they told me that, they were demoing Windows 95. Same conference. So again, we've got stuff now that is in its own little unique proprietary way of dealing with hierarchical file structures and using techniques that come from the data background, and all of these, in particular these two products are constantly evolving and taking on more properties of big data to achieve sharing. So file sync and share products allow data interoperability and another function of big data. So really, I'm thinking sync and share products like Dropbox that will do deduplication of the data and make it device independent. So any file that you put inside Dropbox or any of those type of products, it gets pulled apart from the operating system it's on. So if you're Windows, it doesn't support access control lists. There's none of the underlying Windows stuff that goes with it. It goes up into the cloud, and that effectively becomes an object for the company that's providing it to you. So what then can happen, two big data principles. One is they can deal with deduplication. So, for example, if I'm a provider of these kind of solutions, then the kind of files that people are going to store inside their Dropbox probably can be, quite easily duplicated against each other. So things like Word documents. If people write really, really small Word documents, it deduplicates well because you tend to get all of the headers and all the descriptor files that Word automatically creates inside those files. And maybe like a little bit of text in the middle, which is unique, and then more file descriptors. So those deduplicate well against each other. And the other thing is you get portability. Once you've stripped the ACLs off it and so on, you can give someone a file and then they can download it onto their iPad, which doesn't even have a Windows operating system available on it. So as long as you can get to the app, or as long as you can get a suitable app to actually decode the data, then you have that provided. So that's really what I'm talking about when I'm talking about device independence issues, removing things from a hierarchical and treating them as objects. This also leads to some problems, particularly of relevance to the Isle of Man, because Another aspect of big data implementations is multi-tenancy. And if you're relying on another provider to provide these to you, on the other, particularly data sovereignty is an issue. So to be able to deduplicate data, you've actually got to be able to see all the data you want to deduplicate against. So if it was the Wild West, there was no international law governing data sovereignty, this would be a brilliant issue. So for example, if I'm Dropbox, I can get everyone in the entire world and I can deduplicate all of their data against each other. That gives me a massive deduplication rate. Because whatever I could think of to upload to Dropbox, someone has probably uploaded something that's 99.9% similar before. So that's great. So things have moved on since Dropbox, and we now have more corporate solutions that tie into your Active Directory that allow you to store your own data in a multi-tenancy environment whereby you can only see your own data, no one else can see it, it's encrypted against everyone else, and deduplication can only happen then amongst, for example, if you're a company, can happen amongst your colleagues. So the deduplication rates are lower than the global exercise, but it just goes to prove the point that meshing data sovereignty, which are often thought of as being big data issues, also apply at the small scale as you consume big data services provided by an outside party. Transfer, always a good one. There's never enough bandwidth to really do what you want to do in the world, is there? And often you're forced to go out and use DVDs, DHL, those kind of bandwidth companies. So what we're seeing now is we're seeing more usage of bandwidth reducing technologies. Deduplication is obvious. If I need to send somebody a file at the other end, what we've had in the past is we had like WAN scale products. So you can get the data at your end, you can compress it a bit and do mathematical compression on it, get it across the line, and then re-expand it again at the other end. And that gives you kind of quite, okay compression. If you've got deduplication as well, then if, for example, you're inside the same organization and I send somebody a file which they've already got something similar to, I don't have to transmit any of the deduplicated blocks. I just have to send the object ID to them as a system. So deduplication gives us increases in bandwidth and aids our transfer. We have interfaces like REST, which are becoming more common. And what that gives us is like a standardized way to talk to like different objects. So for example, we have tools like GeoDrive, which will allow us to map an Amazon S3 data store to a network drive on the server. So if we've got like an organization whereby, we want a common shared area between organizations in different countries, we can effectively use REST to publish geocached resources up into the cloud and then bind those back to our Active Directory to give us the security we need and then push them down to our users. So again, that's a technology which, even without having the hyperscale backline, becoming more common. Online backup as well. The big problem with online backup has historically been, do you really have enough bandwidth to do what you're trying to do? Is most prominent on home connections. So say, for example, you've got home workers who are sat behind an ADSL line. Your ADSL line might be like 20 megs coming down, obviously not in the Isle of Man, but it might only be, 112K going up, which is not a lot to push your backups up to the cloud. If you use deduplication technology and you use objects and use a REST interface going back into the back end of it, you vastly reduce the amount of data that you're sending because you're deduplicating the last backup that you made last night. So you're deduplicating across your own data set, so the deduplication rate is extremely high. and suddenly online backup via low bandwidth is a distinct possibility. And then we have archive integrity. Ideally, you would like to do at the back end is, say, for example, your company is heavily regulated and you're forced to keep data for, maybe 5-6 years for regulatory purposes. One of the big problems that you have with existing solutions is that you don't know the technology is going to be around in the same format in 5 years' time. What happens if you're running, semantic backup and keeping the tapes off-site, and you're cycling through them, and you're pooling through all of the data, and then one day you're going to get to the point where semantic aren't going to be in business anymore because they've been bought by backup exec, or the manufacturers of the tape drive are no longer, in that particular model. There are those kind of issues of how do you really know that you can restore data from 5 years ago. You're relying on proprietary software technology and proprietary hardware technology in some cases, and that's not even mentioning things like the integrity of the tapes. This links back to the first point. If you've got some sort of way of archiving things off to a cloud, which is not high speed, at all, you might accumulate a large amount of data over 5 years. It'll all be deduplicated against each other, and it'll all run inside snapshots. So if you ever want to get data back from 5 years ago, you can go back and you can say inside a web interface, reassemble all those objects as they were 5 years ago. It'll consolidate the file, compress it, and send it down to you. So no matter what happens with technology in the future, and bearing in mind that your provider stays in business, or you bring data down just before they go out of business, which has happened a couple of times this year with different providers, you can always get your data back. So it helps with data integrity. Analysis. Again, we've got technology that's out there now. Document scanning and archiving. There's lots of proprietary formats out there for document imaging, scanning, archiving, and working with digital images. All of them tend to rely on, to some extent, a proprietary database or proprietary software to push blobs into interfaces and get them back. If you didn't have to have proprietary technology that was performing that process, if you had things like REST interfaces, if you had deduplication inside the file level, if you had snapshotting so you could bring things back at a particular date, you could achieve document archiving in a much more efficient way. This is also a growing sector of technology. Antivirus signature pooling is a good example of using data perhaps without knowing about it. So antivirus software companies will have feeds coming in from all sorts of different signed up companies, and they'll be looking for viruses and things inside the code. And you start off with something that's quite inefficient. People have got to recognize viruses, you've got to find the bits of code, and you've got to trawl through a lot of data and say, what variants has this got? What do all these variants have in common? What's the thing that identifies this? So that actually, at the virus vendors' point, is a big data exercise, because they've got to trawl through all that data and the rest of it. What they actually come up with at the end of it is they have a very small signature. Once they've done their analysis and been through all the data, they'll just send you the signatures. Those automatically download onto your antivirus protection product. The whole process becomes very, very efficient because you only have to check for that signature inside your files. So they're kind of consuming a big data process very efficiently by relying on someone else to do the big data processing for you. And I think we'll see a lot of technology like that in the future outside of antivirus. Pattern recognition. Can't remember what I meant by that. I think what I was trying to get at is that you have software now which has got pattern recognition. And I remember now, Facebook, when you're doing facial recognition and things like that, obviously you can get the facial recognition through using their REST interface, and you can go in through social graph, and should you know enough people, should there be enough people on your friends list, you can use things like facial recognition. And so they've already done the number crunching at the big data back end, and you're just using a REST interface, and you can pull that data down and you can bind it in with your own data. I don't know quite why you'd want, facial recognition inside, a standard IT infrastructure, but you could do it. And the last sort of example of the way things are going is recognizing dead files. So I was looking through some vendors' research data on what it was they're working on, and they're trying to find a good way of dealing with effectively dead data. So if you imagine that, for example, I'm Twitter, and I have a Twitter account, and I think everyone is really going to be interested in having a quick look at what I've had for my tea. So I've got a picture of my baked potato, whatever, and I post up there as I had this lovely baked potato for tea. No one is going to be particularly interested at the time. I've made a mistake. I'm not going to get too many new followers. And as the years go by, that image will still be inside my account. And Twitter have got to find some way, because they say they're not going to delete stuff, somewhere to store that. So looking at how to build an array with a load of disks in it, which operates with all of the disks almost permanently spun down, and in a low power state, on the off chance that someone is going to want us look in 5 years' time at the picture of my baked potato, the system will go in, it'll identify which disk it's on via the metadata we discussed earlier, it will power up the disk, read the one photograph of it and return it to the client within a reasonable amount of time. But that is, for me, what big data is all about. Finding new ways to deal with data. Certainly a new one. I've got files inside my organisation that are even deader than that baked potato that no one is ever going to look at again. I wish I could find them and get rid of them. Okay, so in conclusion, what are we saying? Even with the amount of data we have now, we're already exceeding the threshold of legacy technology to support the amount of data we have now. Big data technology principles are already in use. Big data solutions are backfilled and deployed from the hybrid and public cloud to support functions we take for granted. So even if I don't have, big data myself, I use Siri. That's plugged into a pretty big data source. So I can consume it without owning the data. The reason we're trying to do this inside organizations is because we're always competing with people who are more agile, who have better access to big data. People will remember, I guess, from the days when mailboxes were really small. There was always an ongoing battle to get a bigger and bigger mailbox from IT. So when the mailbox was really small, I was working as a software engineer, and we would store little bits of code and things that we'd done inside email and the rest of it. Probably wouldn't look at it again. Otherwise, we'd do proper documentation. Honestly, would next time. But the people who won the arguments and had the bigger mailboxes had more code snippets inside them, and they could work faster than the people who had smaller mailboxes. So there were some times when although it seems nonsensical to store things you don't think you might need again, if it's a straight fight between somebody who can get that data back, use it in an agile way and move on, that gives you a distinct business advantage. And that's what we're beginning to see across all of these fields. Really what I'm saying is all of this is converging down. You can buy small scale object orientated storage. Most of these technologies are already inside your organizations, and I think that everyone's on the road to big data or different points along it. Okay, thank you. Open to questions. Excellent. Yeah, I'll do it. It is. I need to give you my microphone as well, don't I?
Indeed. Actually, we need to give Graeme a microphone.
Sorry? I'm just using the arrow keys. Mouse.
Stick that on your belt or something. Where,
Pocket, all right? Yeah. There you go. Right, jumped up. Cool. Do we need to? Yep. Still too small. Have to do. Literally just a lightning talk, just some of the things I've been talking about and playing about with recently in the last, say, half year. This is just any old technical meeting. Get the cough up there. So as I said, yeah, any old technical meeting, a couple of dozen people in the room. What made it more interesting was, it was a couple of weeks ago, it was in Geneva, it was at the United Nations, and that's one organisation with a lot of big data. They recognised a while ago that not only do they collect data for a lot of countries, cross-border projects, the backlog they had of technical requests to deploy that data better, and the possibilities of that they hadn't even thought of, and the timescale to actually deliver some of these opportunities, you were talking years. So they came up with a bright idea, or somebody came up with a bright idea for them. They said, well, if you're not going to get around to it, why don't you let somebody else get around to it? So they bought the open data bandwagon, and they came up with a portal, and they brought a portal out, and so they ended up with data.un.org, and in a very period of sort of time, 34 databases, 60 million records, and that's, believe me, that's a tiny fraction of what they've got. They're just spending more time, like most cautious organisations, and particularly with lots of, whilst it's an apolitical organisation, there's a lot of politics in there. So they spend a lot of time figuring out what they can release and what they can't release, and who will be annoyed and who won't be annoyed. If I give you an idea, that the first half of the meeting was about IT, the second half of the meeting was about Syria, a refugee camp, and how to use open data, big data in a refugee camp. It was actually, and some of the issues were just issues you would never think of. From a compliance point of view, people are saying, yes, there is a complaint procedure if you've been shaken down for bribes to get from A to B and all this kind of stuff. They had all procedures in place, but in the real world, the procedures didn't work. And procurement, in the real world, it just didn't work. So they had, for example, in the data, they had the knowledge that a temporary toilet cost anywhere between $30 and $280 from in the same camp from different suppliers. So why didn't they all use the $30 one? The fact is that no one was keeping control, because it was such a such basically. But by squeezing more efficient out of business case there straight away, because they could save money, they could do more with less, and that's a great call in these days. So they're using, as it happens, they're using CCAN as a portal. It's open source, it's on GitHub, and that's moving into the world of crowdsourced software development. And a lot of people dip their toe in the water with the open source, and how do I get paid for this? It's typically around services or consultancy. It's not about licensing proprietary code. although you can do your own instances of, which a lot of the bigger organisations do now, particularly private sector, like banking and insurance. But within probably 3 months, they're talking about that being 180 million, and within a year, nearly 500, 600 million records. So the scale of that increase is into the big data world. One of the guys there was from the Collider, and he was going, that's not big data. And another guy there, Tim Hubbard, he's like the David Cameron's health or med tech advisor, and he does the 100,000 Genomes project. So I know all about all the issues that are going to kill me now. That's a fascinating lunchtime. So when you've got all this data, you know, Arron touched on it, it's things like you're looking at variances. So great, you've got all that data in all these different countries, but what are you going to do with it? Actually, what you're going to do is you're going to benchmark them. So it's great that the G8 Open Government Partnership, it's part of the commitments that they had in Northern Ireland. More transparency, we all know this in the Isle of Man because we're one of the leading transparency jurisdictions. But when you actually do the actual league table, which hasn't been published yet by the way, what you find is that, of course, the UK is very high up there. They were a bit annoyed that Denmark's beaten them. But way, way, way down is the Isle of Man. You can't actually see the figures there, but it's pretty low. More importantly, we're ahead of all our competitors, which is fantastic news. It is a low bar. It really is early stages of being able to reuse all this stuff. The problem is most of our data is PDFs, and you can't do anything with it. So you'll actually spend more time cleaning stuff up and getting it to a state where you can do anything with it. International aid, the big data database, what's known as the IATI register. Every country that gives a budget for international aid puts the information into there. The idea is that every transaction, every project, everything to do with international aid will be in one place. Again, not a small project. There's nearly 200 organisations pumping data into that constantly. And what's happening now is that there's a whole community of third-party developers, and they are using a standardised interface, standardised data format to do all sorts of visualizations. I just hacked around with the Isle of Man's international aid annual report for last year. Took about 80 emails and phone calls, documented a process, because up until now it's only been about 100 countries have done it themselves, have gone through like a formal process. What they'd never had before was someone say, well, can I do it for my country if they're not going to do it themselves? And they went, you could do, but no one's done that before. So that was an agile process. They went, yeah, all right then, let's try it. So we documented it all. So now anyone can actually upload data for either their country or their organisation or their region, down to on the receiving. So once you've got that database, great, you can do all sorts of these, as I said, these third-party visualizations. Before it was just a CSV of drill down, drill up, and sort of mix and match data across borders in Africa. I knew roughly where our money was going, but I couldn't really see what they were doing with it. And more importantly, how that related to what everybody else was doing with it. Were there any gaps? Were there any overlaps? You know, what we were putting our money against, the Millennium Development Goals. But when you once you start to have everything in one place and you can start to analyse it, you can use big data analytics, you can stuff as Google, all the same stuff as whether you're moving into predictive analytics, you can start to say, well, this area is going to suffer from corruption. You're going to lose money one way or another. We've got the history to compare it against. And then you've got the shift to social enterprise as well. So now you've got this platform where big philanthropic trusts, the likes of Bill Gates, even our local Mark Shuttleworth, they're putting money into foundations, and what they say is, well, I'm only willing to give money to a project that works, I don't want it to be wasted. So it's actually significantly increased the amount of money coming from the private sector, from high net worth individuals, into international aid through impact investing. And of course, man with the offshore finance. And then you've even got big into. I don't know if anybody. I know a couple of you are familiar with Open Corporates. He was a speaker a couple of years ago over here. He started the project with a credit card. Now, over 61 million corporate entities. He's using web scraping. He's using APIs. He's got official support from some countries. Generally speaking, not from most of the countries. And all he does is web scrapes or gets the information from the official registry. But the key to it is it's all in one place. And made a lot of friends over those couple of years. But what they're moving into now is that the trends with all this this kind of technology is people start to think, well, what else can I do? So what's happening now is that they've opened up new features. So they've got things like crowdsourced input from people that know. They say, well, okay, then, well, you've got an annual report for that for Shell. Can you tell me, can you link together all the corporate entities for me? Because I have no way of getting that from a registry because none of them speak to each other. So they're now accepting that crowdsourced data. It gets verified by third parties or official editors. They're putting in things like VAT registration numbers from till receipts, from invoices. And so you've got all the NGOs in all these different countries. They're saying, well, actually, is this company, playing totally fair with this country? Actually, we'll start to register more information. So people can start to do those visualizations that we saw before. And it still is early days. I think you'd agree with that, Arron. It's still very early days. But there's lots of interesting projects going on. And that's the end of my clicks. But as I said, it was literally a lightning talk. I'm happy to take questions, but I'm equally happy to talk afterwards. A lot of the questions probably get very geeky, I'm afraid. So I'll quite happily hand over to Graeme Hurley, our membership secretary. Just for a few